today is something called radian measure. So there are two ways that we can measure angles in trigonometry. We're most comfortable and confident with degrees at the moment, but I'm introducing a new way of measuring called a radian. Now radian is very commonly used in extension 1 and we still use it a lot of the time in advance, so it's just building our confidence with becoming more familiar with it because it looks a little bit different. So then I want to be able to convert between the two, because sometimes you're going to get questions where you feel more confident working in degrees, which is more than okay. You just have to make sure you convert it to the right unit of measure at the end. Then lastly, we're going to look at radians, and we're going to say if we have those exact values, so the 45, 60 and 30 degrees, how can we actually represent those using radians? So the heading, I'm going to start with, why do we measure the unit circle in 360? So can you, in your rule books, copy this down? Because that's the question that we're going to answer today to help us understand why it is that we use radians. Is that the heading? Huh? That's kind of the starter. Yeah, you can call it the heading. Yeah, that's the first heading. And the next heading I'm going to do is radians, actually. So there is a reason why we use 360 degrees. Because have you ever thought why an angle of revolution is 360 degrees? No. We just kind of assumed that that's just what it is. So the reason where this comes about is if you think about several hundreds of thousands of years ago, they don't have calculators, they don't have anything like the resources we have now. So what they wanted to do is they wanted to find a measure that was really feasible to work with. So the first reason is if you think about the number 360, if you think about the factors of 360, it's a lot, isn't it? So it makes it really easy to break down. So the first is it's actually easy to use. That's the first one there. So if you think about thousands of years ago, it's easy to use because it has multiple factors. So I can break up 360. There's 2, there's 3, there's 6, all these different types of factors of 360 degrees. So if I'm a mathematician working through different angles, 360 is really easy for me to break up this particular unit circle into different parts. So that's how it first started. And the second is actually bearings. So if you think about a ship being able to travel in different directions, being able to break up this circle, so think about north, east, south and west, being able to break up those set of directions into really minute and specific and accurate bearings means that ships and other means of travel have a more accurate way of getting to the right place. So that's why 360 is used. So the reason where radians comes in, and that's going to be your next heading down here, so radians is very specific. There are angles defined by the unit circle. So here, I'm going to put here our measure. And angles defined by the circle. Defined by the circle. Degrees we can measure of any. Notice with degrees we can keep on going, but here my radians is specifically when I'm looking at circles.
Is this the pi thing?
Almost. Yeah. And the reason I put a circle, so I'm going to move this up here. This is my best attempt at a circle. Is it alright?
That is very nice.
A lot of pressure. And it's on camera, so I feel it. So here, what I'm looking for, if I think of my circle, if I think of the circumference of a circle, we know that that's 2 pi r, isn't it? Now, if I think about a unit circle, what's the radius of a unit circle?
1.
Excellent, it's 1, isn't it? So the radius equals 1. So if I think about this, if the radius is equal to 1, then the circumference of my whole circle is 2 pi. Would we agree?
Yes.
Yes? So if I think about, if I go all the way around the unit circle, if I go all the way around here, yes, it's 360 degrees, but if I work all the way around, can you see that it's also equal to 2 pi? So here, before with degrees, if I measure the entire angle that this radius makes within the circle, it's 360 degrees. With a unit circle, because my radius is 1, if I work all the way around, it's simply just 2 pi. It is just another way of saying 360. So here, let's do, now I have to do another one. We'll see how we go. All right. So here, I've got 2 pi. And 2 pi, it's almost saying the same thing. It's 360 degrees, but instead I'm using 2 pi. So, hypothetically, if I looked at my circle, again, this is a unit circle. I'll make that note here. Everything is to do with this case just with the unit circle, because the unit circle gives me a radius of 1, which allows me to have 2 pi. If I broke this circle up into a half, roughly, and I measured it, in degrees, what is this angle in degrees?
180.
Good. How much do you think it might be in radians, just looking at what we did before? Pi. Are we okay with that? If I break it up again into a quarter, this here is a right angle, which is 90 degrees. Yeah, pi, half of pi, which is pi over 2. Radians is measuring the angle within a circle, and it always involves pi because we know the circumference of a unit circle is simply 2 pi. I'll pause there. Questions so far? I know. So you are going to see, you probably might have said, I think there was one question that you had before where it had like pi in it. It's talking about radians right here. So, what I'm going to do is I'm going to start with, I'm just going to write down the main angles that we commonly use, and I'm going to write them in radians. So here, what we did is we had 360 degrees. That's the same as 2 pi. I'll write down here as well, 180 degrees is the same as pi, because it's half of 360. Then I looked here at 90 degrees, which is half of 180, so it is pi over 2. So, the next thing I'm going to do is, on your reference sheet, the special triangles are in degrees. You also need to be able to know how to recognize them in radians. So let's start with the 45-degree one. That's what we're familiar with, and I'll mark it like so. Now, the best way to think about what 45 degrees is in radians, I want you to think about, notice that with 90, it was half of 180. So you can think about it in two ways. You can think of how many times does 45 go into 360, so how many times do you have to break up 2 pi? Or how many times does 45 go into 180? 4, excellent. So here, if 45 goes into 180 4 times, then 45 degrees, I'll do this right here, is going to be pi over 4. That's your measurement or your angle in radians. Is that sitting okay? So 45 degrees is equal to pi over 4 radians. 60 and 30. Actually, I'll put a little arrow there. That's what it becomes. And the reason I'm going to have you draw it out like this is because I want you to be familiar with what the special triangle looks like with radians, because this isn't familiar to us just yet. And I want you to feel confident that when you see your reference sheet, if you get a question in radians, that you know what the special triangle should look like. Let's go there. No, jump ahead. So, shall we start with 30? How many times does 30 go into 180? Good, so what's the radians going to be? Excellent. 60 goes into 180 how many times? Good, so what's my 60 degrees in radians is? Excellent. Pi over 3. Unfortunately, this part is a little bit confusing. Notice 30 degrees is pi on 6 and 60 is pi on 3. Just be really diligent when you copy that out. 30 is not pi on 3 and 6. Notice how the 6's, they don't match up. So just be really careful that you equate them correctly. Okay. Now, the way that we denote radians, so normally with degrees, we would typically use the symbol like so, like that little degree symbol. With radians, most of the time you can actually just leave your answer in terms of pi, because by leaving it in terms of pi, we already know that you've used radians. However, if sometimes you might come across, it can be represented by, it's like a little C. You don't see it often, but just in case that you do, it's just saying that it's measuring in radians, or it might just say like pi radians, just the actual word itself. But if I'm being frank, typically like when we're working with it, by leaving it in terms of pi, you've already communicated that you're measuring in radians. All right, I'll pause there. Questions? Feeling okay? Good. Now, thankfully 360 can be broken up into multiple parts, but there are going to be some numbers that don't go evenly into 360. So what we want to do is we want to be able to come up with something where we can convert it. So notice a lot of the time I kept saying 180. How many times is it going to 180? So when you're converting, so if I want to convert, let's start here with degrees to radians. What you need to do is notice that, for example, for 90, if I had 90 degrees and I want to convert it to radians, I'll just do it on the side so you can see here. What I would do is, can you see here that I was working with everything in terms of pi? I need to get pi in there for the radians. And then what I did is I recognized that it goes into 180 twice. Notice I kept referencing 180. So when you convert degrees to radians, what you do is you multiply, let's put it here, multiply by pi over 180. By doing so, you introduce pi, and then by doing 180, you're trying to understand how many times does that number fit into 180. Is that okay? And then from radians to degrees, we simply multiply by the reciprocal, because when you think here, you multiply by this. If you'd like to reverse it, you're going to normally divide by pi over 180, which means you keep change flip. So you just multiply by 180 over pi. The way I remember it, if you're moving to radians, radians needs pi, so you must have it on the numerator. If you're trying to go to degrees, you need to get rid of pi, so you have to divide by pi. That's the easiest way that I tend to remember it. Alright, so what I'm going to do is I'm going to pop up some examples, and I want you to just practice converting between the two. So, let's go here. can you have a go at converting? And now remember, when you're converting, you want to leave pi in your answer. So don't put it into a decimal. We leave pi in there because that's how we describe radians. So leave pi in there. Sorry? Not for this bit yet, but in a moment, yeah. I'll go through that bit in a moment, but not yet for this one because you're going to keep everything in terms of pi. Which ends up being...
Oh wait, no, you're right. I did one.
So, for the first part, so do you want me to talk you through, did we get a little bit lost on the first? Or like how to get it without?
I get it.
What I do is normally on the calculator, I ignore the pi, because the pi is going to remain in the numerator, and it's just 70 over 180, which simplifies to 7 over 18. Yes? Same here, I do 270 over 180, which is equal to 3 pi over 2. Because when I think about it, let's go green. With this 270, if I think about my unit circle, so here I'm at 0. This now is pi on 2, because that's your 90 degrees there. This here is pi. Can you see here that I'm moving up by pi on 2 every single time? So can you see that's why it's 3 over 2, because I've got 1.5 lots of pi. So here, this ends up being 3 pi over 2. So it is okay to have your numerator larger than your denominator, because simply what that's meaning is that you have more than one group of pi, which means it's more than 180 degrees, is what it's saying. If it's worth more than 2 pi, it means that you have a radians that is greater than 360 degrees, if that makes sense. Now, for this next one, well, we know from here that it's going to be 30. But to convert radians to degrees, again, to remember which is on the numerator and the denominator, I want to remove pi. So to do that, it needs to be on the denominator. And then I fill this up here. So I should get 30 degrees. Here I have 3 pi over 4. I multiply it because I want to get rid of the pi. And I times it by 180. Actually, can someone tell me what they end up with that one? 125? 135. Is it okay?
Yes.
Converting is good. The one thing that I am going to get us familiar with is actually solving problems. So everything that we've done with trig so far, so all that equation work, we're going to start looking at it, but in radians. Yes. I know. Alright, let me take a photo. Yes. So, and it's going to take a bit of time to get your head around, but it is essentially, you've got the foundation, so you know how to work the unit circle in degrees. We're just going to do the same thing in radians. So, let's go with 3.
Miss, what is radians like used for, like in life?
Well, it's used for a lot of measurements and lots of angles. So rather than degrees, we'd rather work with radians.
But why would you want to work with radians and degrees?
Because if we're working with the unit circle specifically. But in real life, like for example, a lot of tradespeople use degrees because that's more relevant.
Yeah.
And it probably is more relevant for us, but normally radians probably more, like if you think about engineering and you're having negatives and positives, and you're working also when we do trig graphs, it's also quite nice to work with in radians. But to be frank, degrees is probably what we normally use. I also suggest a lot of students, when they're doing these types of questions, they actually convert everything into degrees and work with things in degrees, then convert it back at the end. So it's completely up to you. So, I've got 3, evaluate using the unit circle. Alright, and I'll walk you through the first one. Let's go, actually I'm just thinking. Yeah, actually I'm going to start with pi and 4. Just going to start with that before I jump into some of the others. We've seen something like this before. Do we recall what's pi and 4 in degrees?
45.
Good, so I'm just going to write sine 45 degrees on top. That's the equivalent. We've seen questions before where it says evaluate using the unit circle of sine 45 degrees. So here, because I'm looking at an acute angle, it's only going to be in the first quadrant. So therefore, sine pi on 4 is simply equal to 45 degrees, because with my unit circle, I'm only in the first quadrant. I've got an acute angle.
And then do you have to do it like using exact triangles and keep going?
I'm just thinking, I haven't put actually, shall we put between, I might put for this one. Let's do, just for this time round, 0 and pi over 2. Because what's pi over 2 again? Good, so all I'm going to ask for is where it's worth pi on 4 between 0 and 90 degrees. I'll make that to start with, because I just want to slowly build our way around the unit circle.
That's what you put.
Now this next one, I've got sine 5 pi on 4 with a domain between 0 and 2 pi. So already, sine 5 pi on 4, now there are 2 ways to do this. You can just convert everything to degrees. So if I convert 5 pi on 4, to convert to degrees, it's 180 over pi. Can someone tell me what that degrees is?
225.
Good, 225. This we know, yes? So here, if I look at my unit circle, I've got all stations to central. 225 sits exactly here. And then what's my reference angle?
45.
Good, so I'm just going to do pi on 4 equals 45, because I'm just going to get us familiar with seeing it more frequently. So here, I'm going to write it in 2 ways. The first way is how to work it in degrees. So I've got sine, 225 equals 45. Actually, no, it doesn't, sorry. Because if I've got sine and I'm in this quadrant, good, it's negative. So what are the values that I can possibly have?
45 and like 180. Right?
Almost, except,
Oh, wait, no, sorry. 360
Yeah.
minus 45.
yeah, because it's negative. And with radians, notice I don't have a negative in there. So it's not even, that in itself is not indicating to me which quadrant, but I knew by converting it to degrees. So here, I end up with 180 plus 45 and 360 minus 45. So I end up with, I've got 225 degrees and I've got 3, just check, no, 35, isn't it? It's 20. However, everything requires me, if everything is in terms of pi, that means your final answer must also be in terms of pi. So yes, that's all well and good, but I need to then convert these into radians because that is how my question has asked me to.
One of those, like the radian from the start, isn't it?
Yeah, exactly. That's the first one. Good. So I've got, so what I write is sine 5 pi over 4 is equal to the first one, so that's easy enough. 315, what would that be? To convert that into radians,
7 pi over 4.
lovely, 7 pi over 4. Is that feeling okay? Yes? Alright, I'm just going to wipe this bit off. So now, I've got those values just here. Oh, yes. Yes, lovely. Now here, I'm going to write this in a different colour. Maybe I'll go with red. Now here, if I think of 225, if I think of, oh, did I just rub it off? Oh, I did. If I think of back my perfect triangles, what is sine 45? Any ideas?
1 over root 2.
Good. So here, can we see that if I simplified it, it would be also negative 1 over root 2?
But like, are you meant to do that in that type of question or not?
Let me just think.
Because up
Yeah.
the top in A, it could also be 1 over root 2. But like, is that what you're meant to do, or are you just meant to leave it like that?
Let me think. Because I've written the question as evaluate. Actually, yeah, write it with that line in it too, actually. Yes. So that would be 1 over root 2. I used the same, didn't I? Yes. Alright. So, the next one here is I'm going to do B. No, I'm going to do C. What have I got? Cos 11 pi.
Do you have any chocolate?
Sorry, 11 pi. Like so. So here, what I'm then going to do is 11 pi over 6. Now if I convert that to degrees, can someone tell me what we get?
330.
Good, 330 degrees. So here, all stations to central. Pardon? Excellent. So here, cos, what have we got? 11 pi over 6. Now we know it's positive. Can I ask, what's the reference angle?
30.
Good. So it is equal to cos. What's 30 degrees in radians?
Pi over 6.
Are we okay with that? So what I'm doing is I'm just showing that I know that cos 11 pi on 6, which is 330 degrees, is the same as cos pi on 6, which is simply 30 degrees. And if I think of cos 30 degrees, if I think of my special triangles, what does that end up equaling?
Root 3 over 2.
Is that feeling a bit better? Alright, let's go with, have a go at, what are we up to, D?
I've got enough space. I need this much space.
I've only got this and one more, that's it. So what I would do, oh bless you, is convert to degrees so you know exactly where you're working. And then it's the exact same thing that we did when we were first learning about solving for the unit circle. I let it equal what the equivalent reference angle is. And I know that cos pi on 6 is the same as 30 degrees, which I know is root 3 over 2.
-2.
So I would convert to degrees and then try and solve from there. Should be.
Oh, damn it.
I've started off, make sure that your starting point for D and E, similar to that, or that you've at least worked, is it,
It's 10, not cos.
oh, is it 10? Sorry, it is 10.
So it would be negative.
Correct, good. Negative what? Negative 10 what?
60
Which is in radians?
pi over 3.
Excellent, good.
Because it's in the fourth quadrant and 10 is negative.
Yes, sorry, I wrote down cos by accident.
Yeah.
So here, 120 degrees, what's the reference angle?
60
Good, which is going to be sine what?
over
Pi over? Good. Now, sine pi over 3 is sine 60. What is that using your exact values? Mhm. And then I'm in the positive quadrant, I'm in the sine quadrant, so everything's positive. And then here 10 is in the fourth quadrant, which is negative. What is, so I've got tan 60. So what's the exact values of that?
root 3, but it's negative. Yeah.
Excellent. Are we feeling okay? Good. Now, before we jump into that, I'll just quickly get this sorted.
Wait, I'm confused.
Which part did I lose you on?
Why don't we also have it in the second quadrant?
Why do we also, wait for this one? This one here, sorry?
It's only where the angle is.
Because it's only where 300 is. I'm only asking for that specific angle.
Oh.
But if I had, for example, if I had, let me think. Just thinking like a positive. No, what if this is what I'm thinking. If you had that, then it's going to be 1 and 2.
Okay.
Or if you, actually yeah, it would have to be like that. Good. Does that make sense? So if, for example, you had an equation like this, where you're given the answer and you have to find theta, then in that case, you have 2 possible solutions. Which is actually a good example, because if I have my 2 possible solutions and I want them in radians, the way that I would work that out, again, this is in radians. Now, normally in degrees, for example, how would I find the angle here in degrees? What would I normally do? Good. And what's the reference angle for this one here? Good. How would I find the angle in the third quadrant? What would it be? Excellent. Then what would it be in the fourth quadrant? Good. So, what I'm going to do is, let's look at that in radians.
Miss, it would be in the other quadrant because it's negative. Would be in the second quadrant, not.
Oh, it would be, yes, sorry. Thank you. Yes, thank you. So I've got 180 minus 60, 360 minus 60. So here, the way that I'd write that in radians, remember how I really emphasised you write it like this? And this is the reason why. What is 180 degrees in radians? Good. What's 60 degrees in radians? Pi on 3. Can you see that? How that looks different? I'll pause there. Because here, it's really easy. We can see that what it's going to be already, 120. But when you're working with radians, you're working with a whole different set of measurement, and it's not quite easy to sight by eye. So that's why I always get you to write this, because you're going to have to write it like this with radians in order to make sure that you get the right value. So here, what's 360 in radians?
2 pi.
Good, so it's 2 pi, take away pi on 3. Can we see that? Then really all you need to do is here, it's going to be 2 pi on 3 for your first answer. And then for your next answer, it's going to be 5 pi on 3.
But like, is that the answer to that question?
No, it's if we had this, sorry.
Okay.
So this is completely separate. If, for example, you had this particular equation, it would be that. This one's fine because it tells you specifically where it wants it. It's when you're given the answer and you have to find the radians or you have to find the angle. Yes. Are you a little tired? Have I overloaded you for the day? No? Okay, so let me think if there was anything else we had to cover. But basically, the textbook questions that I give you, they're only going to be like examples like C, D, and E. I can't recall if there's any in here, but we'll be doing more practice of those a little bit later. Yes, but this is trying to give you an insight as to how we're going to work with radians quite soon.